Hey everyone, I'm Alp. I most likely work on the infrastructure and the infrastructure around the Kubernetes. And this is my slide about tracking the Perpetrator, which is like a quick look at pod evictions. So in this short talk, I will walk you through something that we often overlook at the Kubernetes, which is like a pod evictions. Oops. So today's agenda is I will try to cover the difference between the eviction and the disruption. And then I will try to answer the question that the why pod disruptions are important, and I will try to go through the pod eviction types. So the eviction is the process of terminating one or more pods on the nodes, and it's an API and the mechanism, where the disruption is the event of the pod becoming unavailable, regardless of the cause. So it might be voluntary disruption, which is caused by some kind of eviction, or it could be involuntary due to some kind of hardware failure or network partitioning. So you might actually ask, isn't the Kubernetes eventually consistent? So why the pod disruptions are important? Well, it's important because of the stateful applications. So they might survive the graceful shutdowns, but those unexpected shutdowns can cause catastrophic failures on them. And also pod disruptions are quite important. Who cares about the availability in general? So we will go through those pod eviction types. So let's go with the eviction API. So Eviction API is the mechanism that provides a safe and controlled way to terminate pods in Kubernetes. And unlike the direct delete operation, which is like deleting the pod, it actually respects your PDBs, which is like a pod disruption budget. But the thing is that like the workload controllers in the Kubernetes, such as stateful sets and the replica sets, do not actually rely on them. So that's why they do have their max unavailable field on their spec. So basically, the eviction API is like used quite limitedly. And in general, it mainly used for two reasons. One of them being the kubectl drain command, and the other one is the cluster autoscaler, where it tries to safely remove nodes from your cluster. So the other type of the eviction is the node pressure eviction. So the kubelet basically keeps an eye on your system resources, such as memory, disk, and the inodes. And when those starting to running low, the kubelet may evict some pods in your cluster to avoid starvation and to free up some resources, basically. So those pods get marked as failed, and then kubelets terminated by the kubelet. Well, actually, this one even used the eviction API that we saw before, and it immediately terminates or deletes the pods based on the soft or hard eviction. So basically, the node pressure eviction could be detailed in two types of eviction, one of them being the soft eviction and the other one being the hard eviction. Soft eviction is basically a condition that persists, like if a condition persists over a grace period, then the soft eviction kicks in, and then the hard eviction is basically, as it sounds, it immediately applies and kills or terminates the pods on your cluster. Both of them actually quite configurable by the kubelet parameters, and this is one of the well-documented type of eviction in the Kubernetes documentation, because the ones that I'm coming through is not that much. So the other one is the taint-based eviction. So the kube controller manager heartbeats the kubelet of each node, and then if a heartbeat fails, it actually gives a taint of no execute. And then the taint manager kicks in and watches that node that having the no execute taint, and then it taints the pod. It kills the pod from that tainted node. So, and then in that case, you will see some kind of event like this, which says the taint manager evicted the pod. And again, this doesn't use the eviction API that we stated previously. So you might actually think about this sentence being correct, right? Like the restarting kubelet does not impact the workloads. Well, it does in some certain cases. So the kubelet actually runs some certain predicates before actually allowing or admitting pod to the node. And it's actually quite reasonable thing, because not every time that you use the kube scheduler to run the schedule the pods, because you could either define the spec node name in your pod configuration, or you could have a node selector to assign pods to nodes. So in this case, you will see something like this to actually show up. So we label the node with some kind of role that we define, and we apply a pod with the node selector for that role. And then we will see that the pod is running up without any issues. And then we just unlabel the node and then restarted the kubelet, and we will see that the pod is in the error state. Like literally 30 seconds ago, the pod was running, and the only thing that we did is restarting the kubelet. So how come it actually affect the pod? Let's see. So, oops. So because actually after a restart, kubelet doesn't have any state to load from. So it starts, it needs to implementing its cache from scratch. And in that operation, it actually sees every pod as an add operation, meaning that it needs to run those predicates for every single pod once again. And you can see the official comment from the Kubernetes document, Kubernetes code base, which it says like this can be resolved once we have the checkpointing, but still it doesn't have any checkpointing. So the last actor that I would like to talk about is the pod preemption. So basically the only, like the kube scheduler basically schedules the pods on your node, but it's not only job of the kube scheduler. It also terminates pods from your nodes as well. And the thing is, if a high priority pod is pending on the queue, which is like a pending state, then if the kube scheduler kicks in and tries to space some room for it. And it looks for the nodes running low priority pods and then considers evicting them to make room. So let's see actually how it works. So basically the kube scheduler looks whether if it could kill any pod with respecting the PDBs, and if so, it just respects the PDBs and kills the pods from there, and if not, it chooses the victim pods by the priority, which is like a lowest first, and then try to graceful delete on that. And this is basically the all actors that we talk about, which are causing a voluntary and the involuntary disruptions in the Kubernetes. And that's pretty much it. Thanks for listening.